Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing inequalities, specifically how we can write them if given verbal descriptions or word problems, and we will do it in 5 minutes or less. So before we look at a sample, let's look at some, not all, but just some of the phrases that you will find in these verbal descriptions that will give you a clue as to what type of inequality. So starting at the left, we're looking at greater than. And so obviously if you see the word greater than, that's a dead clue. But sometimes you might see something that says above, let's just say above 90 or above 100, right? So if you see something that's above 100, right, then it's going to be greater than 100. Or if you see something that is larger than 0.75, well, that just means we're going to be greater than 0.75. So when we see more than or larger than, it's a greater than without the equal to, just the greater than on its own. If we want to do greater than or equal to, right, we've got this little line underneath it. Well, obviously you've got greater than equal to itself, but here's one that tricks us up sometime. At a minimum, that means at a minimum or at least, they both kind of work together here. So if you say at a minimum of 70 or at least 70, right? Well, that's going to be greater than or equal to 70. That means it can be 70, it can be greater than 70, but it cannot be any less than. And here we have no smaller than or no less than. So that's another greater than or equal to. So if you see no less than 40, well, then it's going to be greater than or equal to, because that means it can be 40, but it can also be greater, but just not less than. On the flip side, let's see what happens when we're looking at less than or equal to. So less than is pretty straightforward, right? Smaller than 60 would be less than 60. Below 20 would be less than 20. Fewer than 18 would be less than 18. The tricky one here, again, like its counterpart, is less than or equal to. Obviously, if you see that, it's pretty obvious. But no more than or not to exceed. So no more than, let's just say 19, or not to exceed 19. That means it can be, let's make that the correct symbol there. That means it can be 19, and it can be less than 19. It just can't be more than, or it cannot exceed 19, or at a maximum, or at most. So let's say at a maximum or at most 100. It can get all the way up to 100. It could be 100, it could be less. It just cannot be more, or is not greater than. This one is kind of tricky because that is a less than or equal to, is not greater than 50. Well, that means it can be 50. It could also be less than 50. Just can't be greater than 50. So let's see how to do this with an actual problem. So we have the Jones family's at a picnic. They've got slices of watermelon and cantaloupe. And you see the slices of watermelon are going to be X. And the slices of cantaloupe are going to be Y. And each family member will receive 3 slices of watermelon. Remember, that's my X. 2 slices of cantaloupe, that's my Y. And if the number of total slices not to exceed 50. All right, so that's my clue right there. This is going to be an inequality. And I think I'm going to write this in standard form, or something approaching standard form. Now, standard form is really used, right, when we're doing the AX plus BY equals C, right? So we're going to write it kind of like that. We're just going to obviously replace the equal sign with an inequality here. So we've got the watermelon. I've got 3 slices of watermelon, so 3x, right? And then each family member gets 3 slices of watermelon and 2 slices of cantaloupe. So we're going to add those two. That's going to be 2y. 2 slices of cantaloupe. And we know that it's not going to exceed 50, but do not exceed 50. That means it can be 50, so that's going to be an equal to. And it can't go greater than, so not to exceed is going to let me know it's going to be less than. So 3x plus 2y is less than or equal to 50.